look at some more examples of how we can apply plugging in for word problems. It's important to note that word problems are one of the very most common types of problems in the quant section. So this technique, if we master it, can help us on a tremendous amount of problems. And there are a wide range of topics covered. So plugging in can help us when there might be some gaps in our knowledge or in our memory of how to work with those algebraic topics. As we do this, we want to look for variables in the answer choices, and we want to use smart numbers. We have our core list of smart numbers suggested that we can work from to make calculations easy. We also want to pay careful attention to the problem itself, if there are any restrictions on the numbers or any clues that can help us to choose a smart number. Here's our first example. The average or arithmetic mean of 5 numbers is 3x plus 4. One of the numbers is 7x minus 4, and we want to find the average of the other 4. So this problem could be very overwhelming if we start algebraically, but remember, we're plugging in and we want easy numbers to work with. So one of our very favorite to work with when there are no rules in the problem is something very simple like x equals 1. So the average of 5 numbers is 3x plus 4, so that's 7. Well, if there are 5 numbers and the average is 7, that means that the sum of those 5 numbers together is 35. One of the numbers is 7x minus 4, so 7 times 1 minus 4 is 3. So if 5 of the numbers together add up to 35, here's our key piece of logic. One of those numbers is 3, so that means the other 4 numbers add up to 35 minus 3, which is 32. And so the average of 4 numbers with a sum of 32 is 8. The average of the other 4 numbers must be 8, so that's what we're looking for in our answer choices. We're going to plug in x equals 1. We've got A, B, C, D, E written out on our scratch paper so that every time we get a wrong answer, we cross it off and we don't waste time coming back to it. Answer choice A, 1.6. Remember, x is 1, so every time we're multiplying something by 1, it's just going to be that value. 1.6 times 1 plus 3.2, well, that's 4.8. That's not even a whole number, so it's definitely not equal to 8. B, 1.6 plus 4.8, again, not a whole number. Turns out that equals, what, 6.4? Nope. Answer choice C, 2 times x is 2 plus 4 is 6. Not equal to 8. D, 2 plus 6, that's better. That gives us 8. We're looking very hopeful for D, but let's check E because we want to check all 5 always. 4 times 1 is 4, plus 8 is 12. Too big. So the correct answer is D. The average of the other 4 numbers equals 2x plus 6. As we look back at this problem, we plugged in a very simple number, x equals 1, and so we did a bunch of arithmetic and no algebra, and it was much easier than it would have been if we tried to solve it algebraically. Let's get another answer. Walking at a constant pace on flat ground, a hiker can cover m miles in 5 hours. On another day, she's going to walk at the same pace and walk for 1 plus m hours. Now we want to work with smart numbers here, and smart means easy to work with. As I read this problem, I think I'm going to have to figure out this problem using m miles in 5 hours, miles per hour. So I want to use a number that's going to be divisible by 5, otherwise I'm working with fractions. And anytime I work with fractions or decimals, there are more opportunities for me to make small calculation errors and get the wrong answer. It's also just a good practice in general not to choose numbers that appear in the problem. So what's a nice easy number to work with that's divisible by 5 but not equal to 5 itself? Let's say m equals 10 and see where that takes us. If I can cover 10 miles in 5 hours, that means my speed is 2 miles per hour. See how easy that division was because we chose a smart number? On another day at the same pace, I'm going to walk 1 plus m, so 1 plus 10, or 11 hours at 2 miles per hour. That means I'm going to walk a total of 22 miles. Well, not me, the hiker. All right, so we've got our m equals 10. That's what's going into the answer choices. We've got A, B, C, D, E written out on our scratch paper, and we're going to see which one gives us a value of 22. Answer choice A, m divided by 5 plus 1/5. That 10 divided by 5 is 2. If I'm going to add a fraction smaller than 1 to 2, there is no way that's going to equal 22. So A is out. B is just plain old 6. Well, 6 is not 22, is it? Answer choice C, m over 5 plus 5 over m. So we've got 2, we've got a half. There's no way that's going to get us up to 22. We've got 5 times m over m plus 1. 5 times 10 is 50. 10 plus 1 is 11. That's not going to be a whole number. So D is out. We forgot to cross out C. Running out of room, so let's go up here for E. It's kind of an ugly answer choice, isn't it? But we're hopeful that it's going to come out to 22, otherwise we've done something wrong. M squared plus m divided by 5. 10 squared is 100. Still a nice easy number to work with, plus 10. So that's 110 divided by 5, which does indeed equal 22. And with much rejoicing, we choose E. We rejoice because we found the right answer, and because we chose a smart number that was a multiple of 5. That made it really easy when we got to our answer choices to recognize which numbers weren't even going to be whole numbers and therefore definitely could not equal 22 miles. And we also rejoice because we didn't have to figure out this ugly beast algebraically. So, in review, word problems have plenty of opportunities to plug in. Not every single word problem ever, but so many of them we can use plugging in. And we want to really look for variables in the answer choices as clues that we can use this technique even when we know how to solve algebraically. We want to use smart numbers to make the calculations easy, and that means that we want to go off of our list of small, easy numbers to work with and also look for clues. In this case, we saw how divisibility by 5 was a major clue to help us make the calculation simple and get the right answer with plugging in.